This problem and all other data structure problems can be found here at Sarai Studies. Link is in the description box below. In this video, we're going to be talking about union find, and the way I like to introduce this is by thinking of it as a game, specifically a connect the dots game. And just like Uno, there's different ways to play the game, there's different versions of the game. So union find has 3 different versions. It has quick find, quick union, and quick weighted union. And in this video, we're going to be talking about quick find. First, I'll show you how to play the game, and then I'll show you how to translate that into code. So again, I like to think of it as a connect the dots game. So at the end of the day, you're going to have some dots that are connected, and those dots are going to contain numbers. As for some vocab, these dots are actually called vertices. The lines that connect the dots are called edges, and if they're all connected, that means they're part of the same set. And if they're all part of the same set, here's a fact: each set has its own representative. So it's just the vertice that represents that set. For example, if you and your friend are in a club, maybe you will be the one representing the club, or maybe the club president is going to be the one representing the club. But the idea is that there's someone representing the club here. There is some vertice representing that set. It's always going to be a vertice that's in the set, of course. So 4 wouldn't be a representative of the set because it's not even here. Now, who determines what's the representative of the set? It's not us. It's really just the way and the order that you connect the dots that determines what the representative of the set will end up being, and you'll see what I'm talking about when we go ahead and start. So the game actually starts by me giving you a number. So let's say I give you n is equal to 10. What does that mean? That means draw 10 vertices. Now, the first rule of the game is that you always start counting by 0. So your first vertice is going to be 0, and then you're going to continue. So if you count, you have 10 vertices. It's just that the last number you're going to see is always going to be n minus 1, so 10 minus 1, that's 9, because you start by counting from 0. Now, what I'm going to do is I'm going to go ahead and copy this over here, because as I'm doing the connecting, I want to show you visually how they're being connected. Now, recall that I told you that every set has its own representative, but right now, every vertice is in its own set. So this here, right, is the notation for set. So right now, every vertice is in its own set because it's not connected to anything. But if a representative is a vertice that represents all of the vertices in one set, and there's only one vertice, then the only vertice representing this set is 0, and the only vertice representing this set is 1 and 2 and 3 and so on. And so the idea is that the representatives of all of these vertices are themselves at the beginning. So from a programming perspective, you're really starting with an array of integers, and you're calling that array rep. That stands for representatives. So it's just the representatives of the sets that these vertices are in. So let's say that I want to access this representative. How would I do that? Well, I would take the array and then access the representative of vertice 0, and that's going to give me 0. So that's why I don't like calling this array ID, even though Rutgers does that, because I think that's confusing, because really, from a programming perspective, these are the actual IDs, because this is what you actually plug in here. You plug in vertice 0 to get its representative, you plug in vertice 1 to get its representative, and so on. So I'm not going to call this ID so you don't get it confused with your notes, but really, it's ID. I'm just going to call it number for now, and I'm going to do this so you guys get the notation. So all union 9, 0 is saying is, okay, find the representative of vertice 9, that's 9. You're going to go through the whole array, find wherever you see 9, and if you see 9, replace that with the representative of vertice 0, that is 0. So in other words, I'm changing anywhere I see 9 to 0, and then since I don't see any other 9s, everything just drops down. And because these vertices 0 and 9 have the same representative, that means they're in the same set, that means they're connected. So you're going to have to connect 0 and 9. Union 3, 4, that just means find the representative of vertice 3, that's 3. Wherever you see a 3, change that to whatever the representative in vertice 4 is, that's 4. So everywhere I see a 3, that's going to change to 4. If I don't see any other 3, everything else just drops down. Now, these vertices 3 and 4 have the same representative, meaning they're in the same set, meaning they're connected. Union 5, 8 means find the representative of vertice 5, that's 5. Wherever you see 5, change that to whatever the representative of vertice 8 is, that is 8. And since I only see one 5, that's going to change to an 8, and everything else is going to drop down. Since now these vertices 5 and 8 have the same representative, that means they're in the same set, that means that they're connected. So I'm going to go ahead and take 5, bring it over here, connect that to 8. Union 7, 2 means go to vertice 7, find what it is, change every 7 that you see to whatever is in vertice 2, that's 2. So for every 7 I see, that's going to go to 2. I don't see any other 7, so everything's going to drop down. Vertice 2 and vertice 7 have the same representative of 2, meaning vertice 2 and 7 are connected. So I'm going to bring that over here and connect that. Union 2, 1 means find representative of 2, that's 2. Replace every 2 you see with a representative of 1, that's 1. So every 2 I see is going to go to 1, and then everything else is just going to drop down. What this means now is that vertice 1, vertice 2, and vertice 7 are connected. So I'm just going to go ahead and connect these like so. Union 5, 7 means go and find vertice 5, find its representative. That's 8. So wherever you see an 8, you're going to change that to be whatever the representative of vertice 7 is, that's 1. So these are going to change to 1, and everything else is going to drop down. So 1, 1. What this means now is that vertice 5 and vertice 8 are now in the same set as all other vertices that have representative of 1. So they're going to be linked 7, 8, 5, 1, and 2. So 1, 2, 7, 8, and 5 need to be linked. Bring it over here, connect them. Union 0, 3 means find the representative of vertice 0, that's 0. So everywhere you see a 0, you're going to change that to whatever the representative of vertice 3 is, that's 4. So these are going to change to 4. And then everything else drop down. That means that these vertices are now linked with the other vertices that have the same representative. So 0, 3, 4, and 9 should be together. So I'm going to link those. Union 4, 2, that means go and find representative of vertice 4, that's 4. So wherever you see a 4, that's going to change to whatever the representative of vertice 2 is, that's 1. So 1, 1, 1, and everything else is going to drop. Now what this is our latest array of representatives, and they represent the sets that these vertices belong to. And because they all have the same representative besides vertice 6, that means that they're all part of the same set. So in other words, 6 should be by itself, and these two sets connect. And that's it, that's QuickFind. And the reason they call it QuickFind is because the quickest thing about this is using the find method, because you don't actually just use the union method, it's union find. So there's two methods to this game. Find just actually finds a representative of whatever vertex you put in. So if you want to find the representative of vertice 5, well, that's going to go down here, it's going to go all the way down, and it's going to see, okay, the representative at this point in time at the end is 1. So we've already been using the find method every time we had to find the representative of a vertice. And if you ask for find of 4, you're going to see that the representative of vertice 4 is also 1. So if you were just given this and nothing else, would you say that vertice 5 and vertice 4 are in the same set? Yes, because they have the same representative. Now, if you did find of every single vertice but 6, you would get 1, because they're all in the same set. But if you do find of 6, of vertice 6, what is that going to give you? It's going to go and find its representative, that's 6. So if you were just given these 3 facts, you would know that vertice 5 and 4 are in the same set because they have the same representative. But vertice 6 is not in the same set as 5 or 4 because it has a different representative. That's why it's called QuickFind, because this is the quickest thing ever. Union, however, can take a long time depending on how many operations it has to do. For example, here it had to do 1, 2, 3, 4. So the big question is, how can we get union to only do 1 operation per row or per union? And that's where quick union comes in, where the union will be quicker. So we'll figure out how to play that game. But before, let's actually learn how to code QuickFind.